Hello, and welcome to this podcast for radiation physics at Wenatchee Valley College in Wenatchee, Washington. I am Todd Bussey, your instructor, and I hope you find this podcast and all the other podcasts for this class helpful. In this podcast, we're going to be talking about algebra. The first part is going to be about algebraic expressions, the second part is going to be solving equations, and the third part will be variation, direct and inverse variation. So let's first look at evaluating algebraic expressions. The first example we have is 4 times b cubed plus 5a plus 7 if a equals 2 and b equals 3. So the first thing we need to do is wherever we see an a, we're going to put in a 2 into that spot. Wherever we see a 3, we're going to put, wherever we see a b, we're going to put 3 into that spot. So since we have 4b cubed, we're going to take that b out and put a 3 in for it. So we're going to have 4 times 3 cubed. Then we see an a by the 5. We're going to take the a out and put a 2 in for it. So we're going to have 5 times 2 plus the 7 at the end. Now we go back to order of operations. We have no grouping symbols, and so we have to do exponents. Well, we have 3 cubed. We have to do that first. 3 cubed is 27. So we're going to do 4 times 27 plus 5 times 2 plus 7. No more exponents. Next thing we do is multiplication and division from left to right. So we have 4 times 27. That's 108. We could also do 5 times 2, which is 10, and put the plus 7 at the end. So we're going to have 108 plus 10 plus 7. All we have is addition, so we do addition, subtraction. All those added together will be 125. So when we have a equals 2, b equals 3 in that expression, we get 125. The next expression we have is F, or force, equals K sub C, Coulomb's constant. You'll know all of this stuff when we get to electricity. Q1, Q2 are both charges all over R squared, which is the distance that the charges are apart from each other. And you'll notice that Kc is a constant. Q I give you, Q1 I give you, Q2 and R. So we're just going to plug in the values. K sub C is 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. We'll talk about units on that when we get to it. Q1 is 2 times 10 to the negative 6 coulombs. That's the unit of charge, how much electricity is there. Q2 is negative 5 times 10 to the negative 6 coulombs. And the distance that these two charges are apart is 0.2 meters. So we put the Kc in, we put the Q1 in, Q2 in, over the R squared, and now we have to evaluate that expression. Well, we've got to simplify the fraction bars. So the top, we multiply that all together. The bottom, we put in 0.2 squared, and we do that on a calculator, because I don't want to do that in my head with all the exponents. When we do that, we get a negative 2.2475. And the units on this are going to be newtons. You don't have to worry that that's going to work out, but it's going to work out to be newtons. Since the sign is negative, they're going to be attracted to each other. And all of that other physics stuff, besides the math stuff, we will talk about when we talk about electricity. So that's the end of algebraic expressions. Now we're going to go on to algebraic equations and some solving of some of those. So the first algebraic equation that we have is x plus 4 equals 8. When we solve an equation, we want to get the variable, the x by itself, everything else on the other side. So we always have to do the opposite of what we have. In this case, we have a positive 4. So to put it on the other side, we have to subtract 4 from 4. And whatever we do on one side of the equation, we have to do on the other. So we subtracted 4 on the left-hand side. We have to subtract 4 on the right-hand side. So now we have 4 minus 4, which is 0, so that goes away. We have 8 minus 4. 8 minus 4 is 4, so we will have x equals 4 in that first equation. And we can check our answer by putting 4 back in for x. Well, 4 plus 4 is 8. It works. The next equation we have is x minus 7 equals 4. Well, we have a subtraction here. The opposite of subtraction is addition, so we're going to have to add 7 to both sides. So negative 7 plus 7 is 0. That's good. That goes away, so we have x on that side. We have 4 plus 7 on the right-hand side. 4 plus 7 is 11, so we have x equals 7. X equals 11. If we put 11 back into our equation to check, we have 11 minus 7 which is 4, and 4 equals 4. The next equation we have is 4x plus 2 equals 7. The first thing we have to do is simplify addition subtraction. So we have a positive 2, a plus 2. We have to subtract 2 from both sides. So we have 4x plus 2 minus 2. That's plus 2 minus 2 is going to be 0. We subtracted 2 on the left. We have to subtract 2 on the right. So we have 7 minus 2, which is 5. So we will have 4x equals 5. Now we can do multiplication division. Well, we have 4 times x. The opposite of multiplication is division. So we're going to have to divide by 4 on both sides. So 4 divided by 4 on the left-hand side is 1. So we will end up with 1x. 5 divided by 4 on the right-hand side is 5/4. We're going to just leave it as 5/4. The next equation that we have is x over 4 minus 3 equals 6. Well, we have to do the addition subtraction first. So we have a negative 3. The opposite of subtraction is addition. We're going to add 3 to both sides. And so we will end up with x over 4, because the negative 3 plus 3 goes to 0. 6 plus 3 is 9. So we'll have x over 4 equals 9. X over 4 means division. X divided by 4. The opposite of division is multiplication. So we're going to multiply by 4 on both sides. 4 times x over 4, the 4's will cancel, giving us 1. And since we multiply by 4 on the left, we have to multiply by 4 on the right. 9 times 4 is 36. So we'll have x equals 36. The next equation that we have is 4 times a quantity, x minus 2, plus 7 equals 9. Well, we've got to do the parentheses first, distributive property first. 4 times x is 4x. 4 times a negative 2 is negative 8. So we have 4x minus 8 plus 7 equals 9. The negative 8 and the positive 7 are like terms. They're just numbers, so we can add or subtract those depending upon what we have. In this case, we have one negative, one positive, so we're going to subtract. 8 minus 7 is 1. That 8 was bigger and it's negative, so we have a negative 1. So we have 4x minus 1 equals 9. And now we have to do addition subtraction, so we have to add 1 to both sides. So then we'll have 4x equals 10, because 9 plus 1 is 10. And we have 4 times x equals 10, so we have to divide by 4 on both sides. So we have x equals 10/4, but that can be reduced. 2 goes into both of them. So our final answer will be x equals 5/2. And our final equation that we're going to simplify is v sub f, or v final, velocity final, equals velocity initial, v sub I, plus a times t. And I want to solve this for the variable t, which in this case is time. I want to get the t by itself, everything else on the other side. So the first thing I have to do is move the v sub I, the initial velocity, over to the left-hand side. It's positive on the right-hand side, so we have to subtract v sub I from both sides. V sub I minus v sub I is 0, it goes away. But v sub final minus v sub initial is v sub final minus v sub initial equals at. And we have a times t, so we have to divide by a on both sides. So our t is going to equal v final minus v initial all over a, the acceleration, equals the time. And that's solving that equation for t. The last thing that we have to look at is variation. We have 2 types of variation that we are going to deal with. One is direct variation, and this is where as one variable goes up, the other one goes up proportionally to it. So if one goes up by 2, the other one might go up by 2, it might go up by 4, depending upon the constant of proportionality. The equation that we have for direct variation is y equals kx, where k is our constant of proportionality. In the example we're going to use, the k is going to be 4. So we're going to have y equals 4x. That's a direct variation. As y goes up, x goes up. As x goes up, y goes up. So to illustrate this, I just made a chart, plugged in a couple x's. I'm going to plug in x equals 1, x equals 2, and x equals 3, and see what my y values would be. Well, if I plug in x equals 1, 4 times 1 is 4, so my y will be equal to 4. If I plug in x equals 2, 4 times 2 is 8. My y will equal 8. If I plug in 3, 4 times 3 is 12, so my y would equal 12. My x and y could be coordinates on a graph. So in coordinates on a graph, as the x gets bigger, so does the y, and so the y gets bigger, so it looks like that graph. The next variation that we have is what's called inverse variation. In this case, when one goes up, the other one goes down. Or when one goes down, the other one goes up. That's kind of what my income does once in a while. The more I work, the more the income goes down, although it should go the other way. So the equation that we have is y equals k over x, where k is still a constant of proportionality. Another way you will see this sometimes is k equals y times x. It's the same thing. It's an inverse variation. So the example that we're going to look at is y equals 3 over x, where 3 is our constant of proportionality. I plugged in the same numbers for x in this case. And so when I plug in 1 for x, I get 3 divided by 1, which is 3. I plug in 2 for x, I get 3 divided by 2, which is 3 halves, or 1.5. I plug in 3 for x, I get 3 over 3, which is 1. When I graph those ordered pairs, I get a graph that is sloping down. And so it looks like that graph. First it's y is high, then y is low, where x is getting bigger and bigger and bigger. So that's direct variation and inverse variation. And when we get to the meat of some of the radiation and why things are happening, the X-ray machines and all of that, you'll see that as you change one dial, it goes up and another thing goes down. And so we'll need to know direct variation and inverse variation. This is the end of this podcast. And so we will see you next time. Thank you. Goodbye.